I wanted to take you all through this last example that we did in class today, because I think I went way too fast through it. So let's go through it a little bit more slowly. The job is to find the exact absolute max and minimum of h of x. Well, keep in mind that minimum and maximums can only occur at critical values and at endpoints, because we restricted the domain. So the first thing I need to do is find the critical values. So I'm going to find h prime of x, and I'm going to use the product rule, and I'm also going to use the chain rule. So it's going to be the first times the derivative of the second. Well, the derivative of the second is a chain rule application. So that's going to be negative e to the negative x plus the second times the derivative of the first. So if I clean this up a little bit, I get negative x e to the negative x plus e to the negative x. And the next step is to set this thing equal to 0 and solve it. The way it's written right now, it's really hard to solve for x, so I'm going to put it into factored form. So I'm going to factor out an e to the negative x, and I get this. And now I use the zero product property. This one's easy to solve. I get x equals 1. This one, not so easy to solve. I got to think about this. This is 1 over e to the x equals 0. If I have 1 over anything, I don't care how large or how small it is, but if I have 1 divided by a value, that will never be 0. So here, there's no solution for x. So my only critical value is x equals 1. Now, when I go to set up what we call a candidate test, I have to find all of the candidates that qualify for an absolute max or an absolute min. Well, the critical value is one of them, but the other two are the endpoints. We learned the other day that you can have an absolute max or an absolute min at endpoints. So, in this candidate test, I have to test each of these values. My candidates are 0, that's one endpoint, 1, and 3. And to find what the absolute max or min is, or what the value is, I have to plug each of those right into h of x. So this is going to be h of x here. So when I evaluate h of 0, I'm going to get 0 times e to the negative 0, which is just 0. When I find h of 1, it's going to be 1 times e to the negative 1, or we're going to say 1 over e. And then when I find h of 3, h of 3 is going to be 3 e to the negative 3, or I can say 3 over e cubed. These are the values at each of these candidates. Now, the absolute max is going to be the maximum value. And I'm not working with a calculator here, so I really got to think deeply about this, this, and this. 1 over e will always be positive. 3 over e cubed will always be positive. Okay, 0 is obviously 0. If I go to my absolute min, actually I think that's probably easiest to figure out. The absolute min is 0. All right, because the other two are always going to be a positive value. The absolute max, I have to look at 1 over e and 3 over e cubed and figure out which one is larger. It's kind of hard to do, but if we use a little bit of street smarts, I think it's possible. E cubed is a very large number. That's 2.718 to the third power. So when I take 3 divided by a large number, that's pretty darn close to 0. It's going to be closer to 0 than 1 over e. So therefore, 1 over e is actually larger than 3 over e cubed. So my absolute max is 1 over e. And that's how you do this problem using a candidate test.